Welcome everybody. Thanks for being here. As you've heard, I'm David Komet with Urban Earth, and I'm going to be talking about our passive house driven pickleball facility, or maybe it's our pickleball facility that's driving passive house, one or the other. And I just want to start at the very beginning and just say I am not an architect and I am not an engineer. I come mostly from the investment development side on real estate and finance. And there's no way I could have even begun to pull this project out without the team that I've had available to me. And some of you are on this call today. I'm really flattered to see you guys on the call. I've worked with Peel Passive House. I've worked with a number of other people outside our market area because the skill levels here in San Antonio really aren't there yet to really deliver a project completely. Although the community members here have been great in working with me and with other outside consultants, et cetera. And I did want to say before I began that even though it's really not a prevalent thing in this part of the country, at least in San Antonio, South Texas, there's a great deal of interest here, believe it or not. It seems to surprise people to find that Texas is so interested in things like that. But we are working with the city of San Antonio on some affordable housing projects to inform the city how to best invest our affordable housing bond money. And passive house techniques are exactly what we use to design these houses. We didn't say that, we didn't test it for that. We are testing for performance, but we're not going for passive house certification on these houses. But I just wanted to drop that to know that there's a great deal of interest, a lot of excitement about what we're up to, and it is spreading. So Texas Pickle Hall, this is the project. It's a 12-court indoor pickleball facility. I'm sure at least half of you on this call have probably played pickleball. It's got a bit of a cult status at this point in time. We will have one outdoor court, but this is the basic facility. Of course, it's going to look a little different when we're done. This is a rendering from the beginning of the project, but you know how these things evolve. And a little bit about how we approach our project. So, over time, you've heard I've had experience in a variety of industries over time and really kind of grown and evolved to what I would call a high performance development model. We always talk about, we like to do high performance building, passive house, et cetera. But we really look at four key elements when we're doing a project. We always begin, obviously, with the land. And when it comes to the land, we like regenerative land design techniques. It's also found in the permaculture movements, et cetera. An example for that in our climate zone, we're climate zone 2A hot humid. And as Ken mentioned, again, just let me backtrack a minute, as Ken mentioned at the beginning, we have a new chapter here in part because our design solutions need to be different than a cold climate. So back to our process, we do regenerative land design, dry land, rainwater harvesting is one of the primary techniques we would use in this climate zone because our primary challenges here are extreme heat and drought. And so even in the land side, well, in the passive house side, we'll look at performance metrics. We also look at a performance metric for this, and our primary one is we want to plant as much rainwater as we use water to irrigate our landscape. So that's one of our performance goals there. On the building side, obviously, I'm in part of the passive house movement, and very happy to be here. This is my first project. I thought it was going to be easy for me. I thought, oh, a big box, this will be simple. What could be hard about this? No, it's extremely complicated. It's not that easy, but it's been a lot of fun. I've gotten a lot of great support from others, some of whom are on this call, which I appreciate. And primarily one of my interests is in material selection. We'll get into that in a minute, why I have such a focus on that, aside from the methodology of the design, but also the materials are of great interest to me personally. On the project delivery side, we do practice integrated project delivery. I practiced that my entire career in real estate. I didn't know it had a name. It has a name, and that's where we bring everybody around the campfire from day one: engineers, architects, builder, owner, everybody. And some of actually a couple of team members are on this call right now who have been a part of this as suppliers. So we like to involve everybody as early as we can to inform the design decision. And of course, our performance metrics are on time and on budget. From that perspective, but we find that we minimize change orders, we minimize dumpster haul-offs. It's just a way more efficient way to do it and way more productive for us. And I think the literature bears out that that's a very successful way to go. And then finally, on the investment side, obviously, this project has a purpose. Yes, it's to play pickleball, but we also have investors, partners, and this is our own project. So we're looking at financial performance. And that'll be different for every project. There's not a set number or metric that we're looking for, but these do have to pencil out from an investment standpoint. So for me, yes, we're doing passive house, but it's also part of this entire process. We are in a hot, humid climate, and we love thermal mass. I thought I'd just toss this in here for conversation today. This is a project we did about 11 years ago. We called it the 200. We held a workshop and we built this compressed earth block building, including the vaulted roof out of earth block. And so we have almost 100% CEB building, which is machine-made adobes. And then I put a data logger on the inside and one on the outside, and all I did was replicate what probably 1,000 other people have done in the literature, which is this thermal mass really helps me to shave off peak heat, which is our objective in this climate. And the way I got to compressed earth block as a material was really asking the question, how do people that have lived here for a few hundred years solve their climate comfort challenges? And the answer in our area is adobe. Not rammed earth necessarily, but adobe, and I'll show you rammed earth in a minute. But earth and building assemblies work very well. We don't really have a true diurnal cycle. It doesn't really cool off that much at night in July and August to really get that temperature swing, but these are mechanically cooled and heated to begin with. So I'm less concerned about that than I am shaving off that load. And this is just a nice illustration of that. We have focused after that project, we focused on compressed earth block projects. We built a small apartment complex, built another courtyard complex out of rammed limestone, which we really like a lot. Again, all back to this concept of how can I leverage thermal mass to help drive down not only my environmental impacts using earthen materials, but also my operational energy and shave that as well. And that's panned out to be actually true. Now, these projects were well before I knew how to do passive house design methods. So of course we walk them and say, oh, wow, I've just done that a little bit better. These would be even more high performing, but we did get a HERS rating, I think of 54 on the rammed limestone. So for that time and our skill levels and our experience, that was a win. We're very proud of these projects. So that informs this project, right? So we know that we want to find some way to leverage thermal mass because of where this project is located. And this site is in Live Oak, Texas, which is a small city inside of San Antonio, essentially, a small municipality. And it sits on the I-35 corridor, which has got a little nickname of the Texas Innovation Corridor. And this along the I-35 interstate, which runs from Laredo, Texas, I believe all the way to Chicago, actually. But certainly from San Antonio to Dallas is considered this innovation corridor, which is a hotbed of activity. This was a site that we had a different development concept for it. I was approached about doing pickleball. I'll share some pickleball information with you in a little bit so you'll understand why we pivoted. But again, back to that fourth leg of our development process, when we looked at pickleball versus the other project, the performance on it was dramatically better. So we pivoted, and here's where we are. So here's a little bit of information about our climate. For those of you, we're climate zone 2A. For those of you who've been to Texas, you know what it's like in August. It's like Minnesota in February as an equivalent. We're at about 851 feet above sea level, so we're pretty low. Treated floor area for this project is a little bit over 31,000 square feet. It is an urban infill project, and you can look at those temperature ranges that we're dealing with. So we can, get as high as 111 back in 2000. Last summer, I think we were peaking in 104, 105, 107. Nonetheless, that average summer high is creeping up. We keep recording higher summer temperatures. And so I think that bringing passive house design methodologies to these commercial projects becomes more and more important. And again, as my background's in finance more than it is architecture engineering, we're looking at ways to leverage the passive house design methodology to make this project more valuable, to make it a more higher performing investment, not just in terms of revenue we might derive through the project, but also in terms of mitigating maintenance costs and minimizing mechanical equipment, both from an operational perspective and also from a replacement perspective. There's a nice little diagram, little SketchUp model. You can see how the courts are laid out. We've got 2 bays, a 5-bay court, 7-bay court, and then that purple area is where the offices, bathrooms, et cetera are, and that'll be germane when we start talking about the mechanical strategy for this project. And then there's pickleball, which is the whole reason we're even building this building. And the numbers are ridiculous. For those of you who play, you know what we're talking about. Those of you who hear about it, you can see the numbers are actually kind of eye-watering in terms of the growth rates. It's part of what moved us to do this and to continue to look at other opportunities. But this is here to stay. Now, you've seen I've built with rammed earth. I've built with compressed earth block. Believe me, I wanted to build this building out of rammed earth. How cool would that be to have a rammed limestone building designed with a passive house, if not certified passive house methodology, sitting on one of the fastest growing innovation corridors in the United States. So just from that perspective, in terms of communicating the value proposition around lower impact materials, lower carbon materials, as well as the value of passive house from a real estate strategy. We were very excited about doing this, but I couldn't do the rammed earth because I kept running into the question from the banks, from other people. Well, what if pickleball is just a fad and it's gone in 3 years or 5 years, right? It's a legitimate question. I don't think that's going to be the case at all. In fact, I think it's still early days, but I still had to design with that in mind. And so that led us to look at a different material palette and to consider this concept. Of course, you're all familiar with the circular economy consideration. And I had to consider, well, what if pickleball does go away in 3 years? What materials can I build this out of to hit our performance objectives and still make sense for all the other things that we want to achieve? And that's where we get into circular economy. With rammed earth, rammed limestone, it's very difficult to come back and retrofit. You can't really cut windows and doors into it. So I wanted to find a building approach that would allow me to make this simple, fast to build, serves the purpose of the agenda, had minimized our impacts, and could really help me facilitate hitting the passive house performance numbers. And so circular economy was always involved in everything we're doing. And when you see how we put this building together, I think that'll become obvious. And so I needed to find a wall material that would allow me to come back and retrofit and turn this into an office building, a wedding venue, a go-kart track, something other than pickleball. And that led us to the material selections we made for the thermal envelope that are on the slide. And so we're looking for simple, fast to construct, obviously great performance, and we always look to minimize waste. I have a dumpster goal for this project. Personally, I'd like to see no more than 1 or 2 dumpsters coming off this site. That's one of our goals. We'll see if we can achieve that. So this is essentially how we're building this building. For the thermal mass, we selected Hebel panels. We've been looking to work with AAC or autoclave aerated concrete for a long time, just really never had a use application. And this Hebel panels really meet our performance goals. It meets my circular economy agenda in terms of our ability to retrofit this to cut a window into this assembly, for example. It gives me the thermal mass. I like the AAC because it's that nice balance between thermal mass and insulation. It's a nice hybrid project. And of course, dramatically reduced thermal bridging. And that's the orange part in my diagram. On the green part on the top, we're using a metal sit panel roof that has an R40 rating. Just for perspective, in our climate zone, the prescriptive code is an R38. And then for the skeleton or the structure of this building, it's just a bolt-up structural steel assembly. Now, fun note, we're in San Antonio, Texas. We're very close to Mexico. Monterrey, Mexico is about a 5-hour drive. It's one of the manufacturing hubs of Mexico. In fact, all of this is coming out of Mexico. And so there's another agenda here that we've been working on for a few years, which is how do we improve our supply chains and how do we improve our access to high performance products, because we're finding more and more of them in Mexico than we're finding even in our own local market, which surprised us. So this is a very simple assembly. Frankly, we're mostly assembling the building instead of building the building. There's not a lot of fabrication going on site. On the structural steel, there's nothing exotic there. The only thing exotic we did is we are doing a tubular steel triangular truss, which is kind of cool looking for the aesthetic values. But other than that, it's just a conventional bolt-up steel structure. And technically, we could disassemble this entire building. We could disassemble the panels on the roof, panels on the wall, and the bolt-up structure and repurpose it. I don't see that happening, but we're certainly designing with that concept in mind. We have minimal glazing. We really only have this front section. This is the front entrance of the building. Through our work with the city of San Antonio, we've worked with University of Texas San Antonio's Building Performance Lab to really dial in what numbers do we really need on things like our value of our wall, our value of our roof, how are we detailing our slabs, what solar heat gain coefficients are worth investing in, what is our U value. And so we really went through this from a financial optimization perspective, yet also for performance. But we also always want to balance that. So we're looking and saying at this and saying, look, anything above a 0.25 U value, it'll help, but it's from a financial perspective, the investment is not worth the outcome. And we're, of course, we're basing that on our local utility rates. But this has been a great exercise for us and is really informing all of our projects now about what do our numbers need to be on our materials in terms of not over investing for performance. For example, triple glazed windows, I have this conversation constantly. Yeah, of course, the building will be quieter. Of course, it might perform a little better, but is it really worth the investment? And do we need it to achieve our objectives? And the answer is typically no. And so I just wanted to present this as, we don't have much of in terms of glazing in here, but we're very clear about what we need to hit in terms of component specifications and not over invest in driving the performance that we're looking for. Probably the most intensive part of the work here, and one of my team members is on this call, can attest to this, is dealing with the mechanical strategy. Clearly, we get into these high performance buildings where we really need to rethink how we're addressing thermal comfort in the building. We just haven't evolved in our marketplace to be able to design for that. So we have a four-pronged strategy for our climate. And again, this comes out of our work with the University of Texas at San Antonio, where we now segregate these four components of our mechanical strategy. We segregate heating and cooling, we segregate mechanical ventilation, we have dedicated dehumidification. And in this case, in the pickleball facility, we're using the HVLS fans, or high volume, low speed air fans to move air. And that combination is extremely effective. We use it now in our buildings. I have it going on in my building right here. It's great. It allows us to move our set points to that 77, 78 here in this hot, humid climate, and everybody's happy and comfortable. So we've got a centralized heat pump system, and we've got two primary air handlers, including a Swagon RX50 with all the parts and pieces you see here. It was fun for me, and I have a little illustration here in the next slide, but fun for me. I've never worked on a project A like this, B at this scale, and then dealt with the complexity and sophistication of the mechanical strategy. So this has been a learning experience for me as a passive house practitioner. That the one area where I have the most amount of grind in our local market, i.e. dealing with HVAC contractors, the mechanical strategies, I have to really dig in, become much more expert in, because it's so important to driving the comfort in the building and making these buildings really operate. We've got mainly a Swagon system that's handling most of the load, and then we've got a 4-ton unit that handles some other areas. Let me see if I can get to that slide. Here we go. Here's our strategy right here. You can see the Swagon unit in the bottom right, and that green rectangle on the top right is where it sits. Now, I didn't know, but you can see that little box to the right with the red arrow, that blown up area there, that's our event room, our bathrooms, and on the second floor, our offices, and I left almost a 2,000 square foot mechanical room. Just because we had it, number one. Number two, I didn't want to program it until I knew what was going to go in there. And then number three, you can see the size of this equipment for this centralized strategy. What was planned originally, and you can kind of see it, I kind of blocked it out, but if you look around the top left of this drawing, you'll see the bottoms of some squares, and then on the left-hand side, you'll see another one. The original design was to have 7 large packaged terminal units arrayed around this building, with the inevitable ugly ducting crawling up the side of this building, which I was not wild about. But it got me a building permit with an MVP locally who is a friend of mine, which I appreciated. And then we went to phase 2, brought another team in, and we ended up with this design solution. Local MVP is happy to work with us. So this is exciting for me. It's my first foray into using this kind of a strategy, using this kind of equipment. So it's been great learning, and there's no way I could have done this on my own. Diving a little bit into what's really driving our loads, you can see it's the waste heat from occupants. People are running around playing pickleball. There's nothing else really going on in the building. We're not cooking. Domestic hot water, I think we've got a 10-gallon tank for the bathrooms. We don't have showers. And you can see the load that the lighting puts on this building. And this is of particular interest to me. I'm sure many of you have been exposed to the 24-volt DC microgrid stuff from the days beyond and what's going on right now in low voltage lighting, things of that nature. I looked really hard into low voltage lighting to try and cut this internal heat load. And we had a design solution, but what we came away with is we're not quite there yet. We're getting really, really close. But bringing a low voltage system here, we're not stepping down from 120 to 24 or 12 at the light fixture and throwing off waste heat, I think would be a fantastic opportunity for a facility like this to really cut that lighting load. And here's where we are today on our verification. I'm a little bit behind on my homework. I have to redraw because the building has grown by 5/16 here and there, and we need to go back and it's part of the passive house process. Again, it's my first project. I thought my first model was my last model. Clearly it's not. I'm sure I have 3 or 4 more to go. But you can see we're in striking distance of really being able to certify this building. We are thinking about solar. We have a proposal for solar. In fact, it's kind of fun because it's a pickleball racket with a pickleball on the roof made out of solar panels. And we may go ahead and do that. One thing I wanted to touch on was the role of PACE financing in a project like this. For new construction in the PACE program, I don't know if y'all are familiar with PACE, but it's property assessed clean energy funding for improvements and components of the building that drive it beyond code performance. And so in our market on a new construction, up to 25% of this project could be PACE funded for those components and materials that help improve the performance of this building at least 5% above code. Well, all of you know we're far exceeding the 5%. And so that opens up a lot of opportunities. So my Hebel wall panels are a little bit bigger than maybe code would require. Those are eligible for PACE financing. My roof panels at an R40 exceed the code. Those are eligible for PACE financing. Solar is eligible for PACE financing. Our mechanical equipment, because we're driving performance. And the PACE financing, I think, is a great tool for passive house projects because it functions in the capital stack as equity, not as debt. And it's not a loan to the project sponsors, it's a loan to the property itself. So that brings a lot more financial flexibility. We've not done that before. We are doing it on this project. Our solar decision is probably going to drive that more than anything. And so looking at PACE, coupling it with passive house is obviously we're far exceeding the performance requirements of any PACE financing. But that also starts to factor in when we're starting to select materials and components and how we assemble this building. I'm a fan of the energy use intensity metric. I use site energy use intensity. I don't use source or primary as passive house refers to it. We use site intensity because grids are different all over the country. I'm pretty proud of this. So right now we're sitting at an EUI of 17 and the median site EUI for facilities like this. Now, of course, this is a mashup. This is the Department of Energy's mashup of reporting buildings from all over the United States. And it has been pointed out to me, well, you don't have showers, you don't have a kit. It's true, but I have to use some numbers. So we're somewhere around 80, 82 is the median for this type of facility that we're building, and we're sitting at a 17. And so for me, obviously, from a real estate investor perspective, the passive house design methodology, the passive house outcomes tell me I get a better product. If I'm certified passive house, it's a seal of quality in my mind. It's not just performance, it's also the quality of the building. Because obviously, as you all know, to hit these performance numbers, the construction has to be quality. The attention to air tightness has to be there. And one thing I didn't mention, but I will, is in order to achieve that air tightness, I do own a Coltraco ultrasonic piece of equipment. I think you guys may be familiar with that, but it sends out an ultrasonic beam. And so our program here is as the panels go in, we wand them. As the windows go in, we wand them. As the doors go in, we wand them. We want to find those leaks while the contractor's on site to me, that's going to drive speed, it's going to drive efficiency, and it's going to drive quality. I don't want to hunt for leaks. We want to find them as they're installed. So we're pretty excited about adding that component to our QC. And this is where we are today. This building is not built, but you can see some fun things here. We're putting our footers in for a retaining wall, and we've got bolts going in for our steel assembly. You can see we've bermed. One of the performance strategies we use, the site has an 18-foot drop corner to corner. And so instead of stair stepping the building or some other strategy, we're berming the building in on the northern elevation. That helped us a lot in terms of the costs of the building. We brought our building costs down dramatically just by doing this. We also hopefully are improving our performance because this segment of the wall is, I think it's about a 6-foot depth, is not ambient, it's below ground. And yeah, we should be pouring a slab next week. Steel comes in December, and then we start assembling this building. And now we're to questions.
Fantastic. That's wonderful. So yeah, so let's bring in some questions into our conversation. And if we need to go, move forward back into slides, we can certainly do that as well. I think, one thing that jumps out at everybody when they look at this building is the assemblies, right? And the level or the lack of insulation levels is startling. And really being able to drive that in an innovative way in the choice of components and materials. So why don't we start there? And I know there's a couple of questions in the chat. I think I'm curious too. We talked a little bit about the assembly, like those AAC panels that you're putting up, they're mechanically attached back to the steel structure. They're self-supporting, tied into the roof. How are they like sitting there?
Yeah, I think my favorite construction word is clip. So there's a clip, right? So there's a clip where you attach it to the panels and it attaches to the steel assembly, for sure.
Thermally broken clips.
I can't remember how deep they go into the block itself. I want to say 2 or 3 inches. I think actually Paul Brown from Hebel's on this call. Maybe he can drop that in the chat. But I've got the detail somewhere in my shop drawings. But it really doesn't penetrate the wall much.
Right. But presumably it's a metal clip, right?
Yes, that's correct. Yeah.
Yeah, but it's not penetrating that much, as you said.
Correct.
Great. I guess so. There's a question related to, I think, a little bit with the AAC panels. Did you consider a look at in the wintertime conditions any issues around condensation on the surfaces?
We haven't, and I saw that in the chat too. The same thing about rammed limestone walls. We haven't had that at all. I've not built an AAC building, and obviously we have mechanical conditioning going on the inside. But we haven't seen those kinds of condensation issues at all with any of these thermal mass assemblies, whether it's rammed limestone, compressed earth block, or AAC. We just haven't seen it. Yeah. But I will add, there's a question about, in a colder climate, for sure. I mean, look, we get away with this because we're where we are. Hot, humid, we can get away with this thermal mass assembly that if I'm in upstate New York, I wouldn't do, right? You for sure need a thermal break. And that's so if you look at rammed earth, you'll find that typically a detail would be putting some kind of a thermal break in the middle of that wall to help. Right. We don't need it here. The old timers have a lot of rules of thumbs, and we've learned them all from all these guys. And typically it's an hour per inch is the pace at which the heat makes it through the wall. Obviously this is not scientific, right? But I'm sure we can measure it. And so if I've got an 18-inch wall assembly on rammed limestone, for example, I don't have 18 hours of direct sun exposure. And then also going back to the graphic about high performance developments, I don't look at the building in isolation. I look at the building as part of the whole site. The building's part of this site. And so we do things in the landscape to help mitigate. So on our western exposure, we want a lot of shade, right? On our northern exposure, maybe we don't want a lot. On the eastern exposure, we also want shade, right? Because that's where a lot of our heat load is in the summertime here. So we're not just relying on the walls to perform, we're also integrating what's going on around the walls as well. But we have not had that issue here ever.
Yeah. Yeah, great. And I believe it's one of your associates, Paul Brown, wrote into the chat that indicating the 4 inches of insulation, the AEC block that's acting as insulation is outside of that clip, and that there are no cavities within the blocks. And finally, that I think which goes to the point that the interior space is conditioned. It's going to be
Right.
at a temperature and controlled in terms of the humidity levels. So that interior surface should never should be at room temperature, um, and maintain that. So fantastic. On related to the insulation, the air tightness and looking at that, and speak a little bit more about how you're stitching it together. You mentioned a tool. I think somebody asked to get a clarification on what that
Yeah.
air tightness
Yes.
tool was. Yeah, super interesting.
Yeah. So obviously the passive house battle is going to be won and lost on our air tightness. It's going to be the construction details. So, we've already had a couple of meetings with the contracting crew and discussed with them the importance of this. We had a rammed limestone house we just finished for the city here. We were training them in a little bit about that. And the tool that I'm using is from Coltraco, Coltraco. I'm pretty sure that Source 2050 carries it. I think that's where I got it from, actually. It's a British product that was developed by the British Royal Navy to detect water leaks in ships on airtight doors. But essentially, you're sending an ultrasonic beam and you're finding where the leaks are. The beam won't penetrate where there's no leak, but it will where there is one. And so it's just part of what I put into our process is if you're installing a window, one of us is there with the wand. And when you're done, we're going to wand it immediately. And so that's one of the reasons I did that. I did it specifically for this project because it is going to be the air tights. All the components are great. All the parts and pieces are great. The design, we like the design, we like the contractor, but it's the air tightness and all those joints. And we've had a lot of conversations with the Hebel team about that, how we're going to ensure air tightness with the panels, where the panels meet the roof panels, all of that is where that's going to be where I'll be focused as the building goes up.
And it looks like when you ultimately do a blower door, you will have it will still all be exposed. It's not like
Right.
there's 10 layers in the assemblies.
That's right. That's exactly right. Yeah, and that's again, you see, and this is something that we're bringing from the rammed earth world, which is in a rammed earth building, my wall is my structure, it's my insulation, it's my interior and my exterior sheathing. Instead of 7 trades and 28 components, I have 1 trade and 3 components. So it's an exercise in simplicity, and that really informs this. Again, doing rammed earth here would have been amazing just because it would have been super sexy on the highway. But the practical aspects of circular economy, the other things we've talked about, really brought us to the Hebel product, which we're happy about. But it's really an exercise in simplicity. The complexity, to your point, is where the joints are, where these components meet, is where this battle will be won.
Yeah. So moving a question, going from the rammed earth to an AAC-based aerated autoclave concrete, which has a lot more voids in it. So it has a much greater insulative property. It's used, Passive House has used it more typically as thermal break material in an assembly that's otherwise CMU concrete or supported concrete of some type, to have that insulation continuity through the structure, that resistance. Where are you sourcing these panels from? And what was your transition in thinking? Like, what have you had to adapt in terms of how you're approaching it, looking at the AAC versus what you would have done otherwise?
Yeah, so the Hebels is manufactured in Monterrey, Mexico today. I know they're working on a U.S. plant, but it is a U.S. distributor we buy through. And in terms of what we've had to do different, I mean, it's a different assembly. So we're not putting up forms, doing engineered mixed designs on crushed limestone, we're not doing all the testing, forming, compacting that we're not manufacturing in the field. And that's part of the reason we've liked earth and building assemblies over time is We're using very low impact materials that are literally probably from down the street, certainly engineered, but manufactured on site. So there's a labor and a jobs component and a story to that. With the Hebel, of course, we're not manufacturing on site. Now we're moving to assembly. And so the main difference is going to be is training the crew in on how to stack these blocks. The panels. They are tongue and groove, and then how we detail the butt joints of these panels as they butt together. That's mostly what is going to be the difference. But truthfully, when you work with great builders, which we do, then great builders are great builders. It's just a matter of making sure they're properly trained.
Yeah, yeah.
Yeah.
Another aspect of the assembly, the floor. We had a couple of thoughts there. One question related to pickleball and the performance and what may need to be treated there differently. And then another regarding the insulation, whether we have under slab insulation,
Yeah.
how far, if we do, what's that look like?
Yeah, and I could have provided a therm diagram for you to speak to that, but as far as pickleball is concerned, nothing special. Well, I say nothing special. I mean, we're bringing out the laser screeders and all the A team because this floor is where we make money in this project. So it's very important that the surface is really well detailed. There's nothing special. I don't think we're using a special high PSI concrete. We were extremely fortunate on this job as we have a lot of expansive clay soils here in San Antonio. If you're to the right of I-35 or the east of 35 heading north, then typically just assume you have expansive clay soils. This site, interestingly, is at the bottom of a little watershed in this area. And if you saw on that cutaway where the current construction progress, there's a tremendous amount of gravel in there, and it's like 4 to 6 inch rock. We didn't know this, so I'm assuming this is an ancient riverbed of some kind. So back to the sustainability program, we have discovered a treasure trove. We should have been mining this site for rock. So we have mined this site for rock. As we've cut through this site, we have been screening out the rock. So instead of building a metal or wood fence, privacy fence along the neighborhood boundary, we're doing gabion fences filled with the rock from the site. It's given us a lot of material for landscaping the site. So that's something we do in the regenerative land spaces. I like to count yields. How many yields am I getting? We got a building, we got profit, we got rock, and then you saw the pad site was this beautiful kind of creamy white limestone. That's site material. We didn't have to bring any of that in, and that was a huge win. So that translates now into the foundation. It's saving us enormous amount of money on concrete beams because the prepared slab is so robust. And in terms of insulation, we are not going to insulate underneath the slab. Again, back to our work with UTSA, it does not pay in this climate zone. Where it does pay is if I have exposed slab edges. There I do need to insulate, shade, berm, do something. I cannot leave that exposed ambient. That does have an impact on performance because that will telegraph. That is a thermal bridge into the building for sure. Yeah. So that's on our radar. Looking at the plans, I can kind of assess what that looks like in terms of feet above grade, et cetera, but you know how that works. We'll wait until we get the final site, the slabs finally poured, and then we'll detail that. Probably with rigid insulation on the south boundary. The northern elevation is already bermed into the hill, and the east-west boundaries are also bermed in for about half of the slab on that side, and then we'll just detail that out with insulation.
Fantastic. Yeah. Perhaps slightly related, thinking about the last assembly piece, the windows.
Yes.
And I know we had previously, there was a conversation about, proposing to put skylights in the roof and have some daylighting and or not to do it. And you chose not to do it. It's about as close to a thermos as I've seen, except that like a paper thin thermos.
I know.
Which is kind of ironic. And so if you could just lead us through the thinking a little bit that you have created a black box, like it would be a great movie theater as well. What, that process of where you landed.
So in the past, I have done a lot of work in controlled environment agriculture. And this conversation is front and center whenever you're trying to grow food, medicine, whatever, indoors. I've been doing this math now for years, and I've come to a conclusion So I can put skylights in this building, but now I'm increasing the heat load on this building, and my primary surface I'm concerned about in this climate zone is my roof. That's where I really need high performance. So I'm really reluctant to put any perforations of any kind into the roof of this building. In fact, we don't have any. So that was one of my performance goals, to have zero perforations in this roof, or as few as possible. But I think we're at zero right now.
Fantastic.
Uh, yeah. So if you're going to create a thermal condition inside the building, let's talk about growing food, strawberries indoors. If I'm going to grow it in a field, then I have the risks and the impacts on production that we can all think about, right? Dust, wind, hail, insects, all this stuff. So you move into a greenhouse. Well, in a greenhouse, my light is kind of free, but it's not really, because you still have to supplement with greenhouse lighting. And I get lousy thermal control. Now you can put blankets on. There's all kinds of strategies to do things, but there you're winning on the lights. You're losing on thermal control. You go indoors, you maximize my ability to control the thermal conditions, but I get zero ambient light, and I'm spending my money on lights. That's why I'm so interested in these microgrid technologies to lower the heat loads on these lights. But I just the over and over and over every time we run the math, and I looked at putting cow wall into here. I looked at it all.
You did.
I did, and it just again, it has to pencil out too. So for the investment in a skylight or a cow wall on an elevation here, what am I getting? I still have to put lights in. I'm not lowering my lighting costs.
Right.
What I might lower is, I guess, the amount of light it might use, but we're pretty low energy already. Number one, just over and over, every time I do this math, I come to the place of, if I'm trying to drive performance around growing food or people playing a sports indoor, and I want to create the perfect environment and keep my energy costs low and keep my impacts low, then I'm going no windows, no skylights, and I'm going electric lighting. Every
Yeah.
time I do the math, that's where I end up. So you're right. We built the thermos, and it looks thin, but really for our climate zone, it's not. Nothing above an R20 wall assembly here in this climate zone really adds value. In other words, the additional expense just doesn't drive much more
Yeah.
performance. That's where we've ended up. So I love the wall assembly we have. Again, it's simple. It looks thin to you, but performance-wise, it's penciling out great.
That's wonderful. Yeah, but I
Yeah,
mean, the energy demand, the heating, and the cooling and dehumidification demand
yeah,
are so low. With that, the heating is like a tiny fraction of
yeah.
allowable. Uh, I imagine it's not broken out, but the cooling must be a relatively small part of that cooling and dehumidification. Um,
Yeah,
really,
now you're getting into one of my weaker areas of the mechanical area. Yeah, what the engineers have told me is you don't have much of a heat load, because David and Ken are out there running around smacking a pickleball, generating a lot of heat. You'll have it in extreme months, but generally there's not much. And of course, we're keeping our cooling demand low, because we're keeping the heat and humidity out of this building. We have virtually no windows on the building, which were allowed by this building type. So yeah, so in some ways we're lucky because it's easier, because I don't have a lot of windows, but it's it's it's
yeah,
still difficult. Yeah,
yeah. Well, let's talk a little bit about this, your strategy and thinking around the temperature control. I don't know if you dove into that too much earlier, in terms of comparing to other gymnasiums, indoor pickleball facilities,
yeah.
what you were going for and your strategy to actually achieve it.
So from the very beginning, there was the business plan, right? The business plan came first. We're going to build a pickleball facility, and if we're going to build one, it needs to be. I wanted it to be, I'm going to say, pro level. All the courts are to regulation spec. All the lighting is to high level of play. All the clearance, all the values around pickleball need to be not perfect, because nothing's perfect, but really, really good. Um, yeah, I give me the second half of your question again.
Yeah, well, I think maybe I was hoping I was leading you there, but maybe I wasn't as explicit enough. When you had talked about the temperature ranges that you were going
Oh,
for
yeah,
and your strategy between the
right,
fans and the straight up mechanical systems,
yeah.
how you were able to tweak things, you think, to create an optimal environment?
Yeah. So here, obviously, reducing humidity is everything. It's really, in my opinion, it's the key to comfort here. The goal was to create, again, the optimal playing experience. So what does that look like from a heating and cooling perspective? My goal was to hit the passive house set points of 77 in the summertime, um, which would be comfortable if we were focusing on dehumidification. What I have seen when I have traveled to other indoor facilities, it's always easy to knock other people's projects and pick on them, and people will come and pick on mine too. But the thing I kept seeing over and over again is, wow, it's humid in here, or it's too cold in here, right? Why is a set point 65 degrees? We've actually seen that. So I'm playing and I feel like $1,000,000, but I sit down and I'm freezing and I'm cramping. And so my goal was to, I don't want to create this like you're playing in an office environment where it's 72 degrees, but I do want it to be a very comfortable 77 dry. We want those HVLS fans with a gentle breeze, 5 miles per hour, kind of cascading over your body, and just create that general feeling of just in a perfect environment with no wind at about 77 degrees and dry, and not have this experience of I'm great when I'm playing, but I'm freezing when I'm sitting, or it's just too humid, or we didn't pay attention to fresh air exchange. That's really, we're using that as a competitive advantage for this facility, is that the air quality indoors in this facility is superior probably to anywhere else you're going to play. So it's part of our competitive advantage conversation. We want this just to be a great. It's not only the court's great to play on, the environment is great to be in, and then that feeds our community values. It's the first thing we wrote. We're a culture-driven facility, so our values are around community, inclusivity, sportsmanship, all that stuff. All of that is in alignment with those concepts in our minds.
Fantastic.
Yeah.
A couple things to follow up on there regarding the comfort. I mean, it is remarkable. We've all experienced that. You go into the shopping mall, you go into the movie theaters down south in particular, but even up north when it's hot in the summertime, hot and humid in the east. Uh, and some relatives' houses, I walk into them and I like need to put on a parka, right? Because they're just
Yeah.
refrigerating them down. Um, and to be able to have to be able to hit that and deal with the environment. I mean, this is the whole, everybody acts like hot and humid is this mysterious thing in the world of passive house, but if we know what we're identifying and tackling it, it
Yeah.
doesn't need to be so mysterious, perhaps.
No, it
um,
doesn't. And I think, I began by saying, and I believe this, we should always look and say, well, how did people solve these problems 300 years ago,
yeah.
right? What are the materials here? They're probably the least expensive for me to get my hands on because they're local. What are the strategies? Obviously here, shade is critical and crucial. It's great. And again, some of the thermal mass comments I've made. If you look at historic houses here, you'll see they have 14-foot ceilings. They might be built out of either adobe or cut limestone blocks. That was originally, we wanted to build this out of cut limestone blocks.
Mm,
I see Tad's on the call here. Tad and I had some really great conversations about, wow, how are we going to do that in passive house? And I finally pivoted away from that because I was really not convinced we could make that an airtight assembly.
yeah.
But yeah, I mean that's what you see.
Yeah. So, and to that, Tad had asked about the acoustic quality of the AAC panels. Do you have a sense of that's going to actually add an additional benefit?
I don't know because I've not been in a building of this volume, of this makeup with the AAC. I think from what I've read, it's better than poured concrete. It's a little more porous, but that's a great question because that is going to be a critical component here. One of the biggest complaints about pickleball, if you're playing outside, is the neighbors and the noise. And if you're playing inside, you don't want all this reverberation, and it is a real problem in some facilities where you literally can't hear your opponent call out the score. So that acoustic issue is on our agenda. I can't answer the question right now, but we will be. There's a section in the building at the entry where there's some opportunity to really create a lot of acoustic baffles, which we've already detailed. But the Hebel walls themselves, really the only thing I have planned for the walls right now is padding to about 8 feet all the way around the building, which will help.
Great, great.
Yeah.
There's a question about the air outdoor air quality because of the highway nearby. I'm wondering if you may speak to that and why, what Passive House and what your ventilation system is doing to deal with that.
That's a great question. I had somebody else ask me about that. I don't know, tell you the truth. I mean, we are right next to a highway. 270,000 cars drive by this site every day. It's extremely busy. I'm sure it's an issue of some kind.
Oh, I thought I threw you a softball. I'll answer.
No, no.
This is
Oh,
one of the great benefits of Passive House because you have that fresh
right,
air ventilation. So we're airtight.
right.
The polluted air can't just blow through the building. At the same time, that ventilation air that's coming in is being filtered.
That's right.
And you can have a high level of filtration. With colleagues in California that no longer call it an airtight building, they call it a smoke type building to address the wildfire
Oh,
smoke
interesting. Yeah.
issues, right? So passive houses will perform much better through wildfire smoke condition, which is extreme to say the least. And so multifamily buildings more and more are being built along highways, right?
Hmm.
And having passive house quality of air tightness coupled with the filtered ventilation gives you
Yeah.
the best possible indoor environment that you could have.
Agreed. And
You just
and
have, you just have to change your filters.
that's right. And then our intake for the ERV is on the east side of the building while the highway's on the west. So at least we're not pulling from that area. But
Uh-huh.
I've had this question. I've not tested the air quality around the site, but certainly being next to a major highway, I'm sure there's some science on this.
Yeah.
Yeah.
I'd like to ask, maybe close with what may seem like a leading question is kind of like, with your experience in doing buildings and in business, kind of tell us just a little bit about your Passive House journey up to this point. Like, how did you hear about Passive House? What did it click? You talked about working with the community in San Antonio, and this is kind
Yeah.
of part of your DNA. Um, yeah,
Yeah.
yeah. What?
So how did I get to Passive House? So as you can see, I was doing compressed earth block, rammed or all this stuff, a lot of green building stuff, and probably like a lot of people on this call, what am I reading at night? I'm reading permaculture books and earth and building engineering, all this stuff. And I said, look, I like structured learning, so I went back to graduate school in 2019, right before the pandemic, and did graduate work in green building and community sustainability. And in there, my coursework was things like design of renewable energy systems, life cycle assessment, et cetera, et cetera. And one of them was the design of net zero buildings, which was a passive house class. And that was Paul Orma, who's presented here to PHN.
Yeah, good
So
friend of the.
it's his fault. So he got me, and before I'll be honest with you, while I was really doing a lot of the original work in the green building space, I knew about Passive House, and by the way, I lived in Germany for a couple of years. I'm very familiar with the culture, the mindset, et cetera. And I looked at Passive House, said, of course, we're going to build this airtight building, and we have to rely on a machine to stay alive, which is not true, right? That's not true, but that was what was in my head. I took Paul's course. It really inspired me, and I really chose to dig into that because what I really liked about Passive House as a numbers guy is I know when I've won, right? I know when I've succeeded in my journey because I have a number, I have a metric, I have a goal. I also really appreciate the Passive House approach to. I really don't care how you build this building, just hit these numbers. You want to use mud, fine, use mud. I don't care, just hit the. So I really appreciated that, and so the more I got into that, more it really appealed to kind of the engineering piece of my brain, somewhere in the left quadrant, that just really it's satisfying to sit and model and design pH and think through all the stuff I've been doing with pen and paper. Again, I'm not an architect, I'm not an engineer. I had to spend a whole summer learning SketchUp just so I could use design pH. I'm still mastering PHPP with a lot of help from my friends in the movement. So I would say for me, it's been great because there's a lot of things that I have done in the past that really support what I'm doing in the passive house. And to me, it's yes, climate's important. Yes, planet health is important. Yes, human health is important. But for me, it gives me a methodology to to really wrap my head around and design against and think through in terms of all of the projects we do and how it adds value. So if we're working on an assisted living project right now, we can all imagine how that helps with something like that. And then in terms of my interaction with the community here, it's been really fun because I have friends who are in the oil and gas business, and we have lively debates about environment all the time. And I've had to adopt and I've had to learn, and I think we all have to. All of us in the hot, humid climate zone are typically running into these objections. Oh, it's going to cost more money. Well, not really. You just have to use your brain. And typically it devolves in a conversation of, well, I don't know why you wouldn't want your real estate to be worth more money. Well, I do. Well, let me show you how this drives that. And so we come at it more from the financial side because that's what drives the conversation here. Climate does not drive the conversation here. But more and more, you guys have seen, we had the Snowmageddon 3 or 4 years ago. We've got Texas grid instability and massive population growth, reshoring and manufacturing. We'll have grid challenges. We'll continue to have them. And so as we engage more with the city on these affordable housing initiatives, I didn't say we're using Passive House. We just used it. And the head of the UTSA's Building Performance Lab was the only other PHI guy in Texas. He's since moved to Pennsylvania, but he's still working on this project, right? So we're doing the design with the Passive House. We're not calling that. And now the staff at the city is so fired up. They're out there taping Mentos wrap and checking windows, and they're wrapping that. It's generating a lot of excitement without calling it anything. Just a better way to build and a healthier building for people. And then the last thing I'd say is, look, this is a Hispanic dominated community. I think 65–70% of our community is Hispanic. Family values are really important in the Hispanic community. And I think, language around that is the health of our families, the health of our children, and how these design methodologies really help with that. Okay, at a pickleball facility, is anybody thinking that? Well, they weren't thinking that, but we're certainly talking about that. Like, why wouldn't you want to play somewhere where you know that the indoor air quality, whether you're concerned about COVID or highway off, whatever it is, why wouldn't you want to play in a place that's healthier to be in? And that's where we find the greatest amount of traction.
That's fantastic. Yeah, there are lots of pathways to the aha with Passive House.
Yeah.
Wonderful. This was a great presentation, David.
Thank you.
Look
Thank you
forward
for
to
having
hearing
me.
in the future about your progress and other great ventures. We encourage everyone who's interested in hot and humid climate Passive House to participate in the new Gulf Coast chapter. We did identify it geographically with the Gulf Coast as the center of hot and humid in the US, but certainly there are other regions that are qualifying up the eastern seaboard and so forth. So welcome everyone to participate there. And we hope to see you next time. So thank you all. Have a great day.
Thanks.
Thank you, David.
You bet.